All right, very good. Thank you, Brett. And thanks to all of you who are hanging out late on Friday afternoon here. So I am going to talk to you about a CLIPS selection for a NASA provided payload that's set to go on the Astrobotics lander to Lacus Mortis next year. The delivery of this magnetometer is this year, midsummer, and the heritage of our Fluxgate has, for example, we have been to the moon before. We have been, we were manifest on Lunar Prospector, and we mapped the global magnetic field of the moon in 1998 and 1999. So I'm going to see if I can come up with the next slide here. Why doesn't it go? There we go. Okay, it's just slow. Okay, so basically the B field guides charged particle and energy movement at the surface of the moon. The team that we are working with here at Goddard has built the magnetometer for MAVEN, Juno, and Parker Solar Probe within the past decade. So basically this is a TRL-9 mission magnetometer, a rad-hardened 10 hertz vector sampling rate, with a 2-meter deployable boom with frangibles that is deployed after landing. We have a 10 picotesla RMS noise floor, and it doesn't really require much in terms of power or weight. We operate in cruise, undeployed in the Earth's magnetosphere, and before deployment for assistance with calibration and offset. And I'll go to the next slide. So this is basically the science case that we made prior to selection, and I show below the latest magnetic field map from Lunar Prospector, which is still being exploited more than 20 years after the end of the mission. So with new techniques, old data is still very useful. But in any case, we're talking about a very different kind of data. This would be the first time we are to the surface of the moon since the Apollo era, and so we're going to see a lot more detail here. We heard from Bob Grimm about electrical conductivity and how we can do that here. We hope that there will be the magnetometers circling the moon, so we can constrain it. There is a local, probably remnant magnetic field in Lacus Mortis, probably less than 5 nanoteslas, but it's probably locally much larger. So we'll learn something there. And one of the primary reasons for doing this is to investigate hydroxylation by the local magnetic field. And this will be basically entails comparing the results from M cubed at basically 2.8 microns. Okay, so this is a more detailed perspective on the new model using the Lunar Prospector data, and we use only the along track radial magnetic field gradients, and we use a different basis set. So this is a paper that's still in review at JGR, and I'm just showing parts of it. But basically the basis set is between 20 and 30 kilometers, and the basis functions uses monopoles. And we show the magnetic field at the surface of the moon, but of course the resolution is comparable to the altitude of the satellite, which at closest approach was between 20 and 30 kilometers in general. So we highlight the Nectarian age basins in the circles and ellipses there. And in some of them, you can see features, magnetic features, probably associated with the Nectarian aged dipole field on the surface of the moon. Okay, so here's a description of the instrument and the current status. And you can see where we're located on the lander. This is the Astrobotics lander, where the mag there consists of a sensor on an extensible boom, basically a boom harness and an electronics box with a power supply and a sensor board. So the instrument build is nearing completion. Next steps include tuning and laboratory thermal testing. Here are some pictures. The Fluxgate power supply and analog boards are populated. The sensor has been built. And the boom for the sensor is in final design, prototype testing. So basically the TRL assessment, we have been flying these magnetometers for 30, 40 years. Mag sensor and electronics are TRL9. The extensible boom is a new design to FTRL6. Mag environmental tests are the next major milestones. And as I said, summary, this will be the first landed magnetometer since Apollo. We continue to improve our global magnetic field models using our previous magnetometer from Lunar Prospector. We hope that the orbital Artemis mags will still be operational so we can look better for the electrical conductivity. And of course, as we heard from the previous talks here, further magnetometer measurements will be performed in at least 2 other landing sites. There is a final thing I'd like to mention, that we have further missions in development, and they include a tethered mission for acquiring magnetic field data from just a few kilometers above the surface. That's led by Tim Stubbs. And I think that's it. That's all I have. Thank you. Questions?
Thank you, Mike. Yeah, we have time for questions. I'll give people a second to add anything to the chat here before stealing that time to get us. Actually, we're getting close to back on schedule here, so thank you.
Good.
Thank Goddard.
Thank you.